Very good morning, good afternoon and good evening to all the participants, students for this NPTEL MOOC course, the title of which is Application of Forecasting, Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as you know, the three main areas for this course, which is a 30 hours course, the three main areas which I was mentioning are the averaging techniques and forecasting. The first one, the second was is regression models, even though it is written multiple linear regression, but we have considered other non-linear regression concepts also, probit and logit. And the third part is time series analysis. So, we are in the last part, which is time series analysis, and this is the last week 12th week lecture number 59. So, what is the coverage? Coverage would be GARCH models, what we mean by volatility clustering, we will show that with examples. Box-Pierce, the algorithm will mention the results. As I said that considering time series is quite mathematical and technical, face to face for an advanced master's degree, I would have discussed all these proofs and few of the lemmas, but considering we only need the application, and once people understand, they can use any good coding software, obviously after understanding, to run these models. We will just mention about A-GARCH, auto regressive GARCH process, and later on we will again visit A-GARCH, E-GARCH, M-GARCH later on. What are these terms? I will just mention them with the bullet points. The conditional heteroscedasticity concept, conditional variance concept, we will just touch through as we progress. So, now as this slide was also shown in the last lecture, I said that we will discuss starting the 59th lecture. Here we are. So, we will consider generalized autoregressive conditional heteroscedasticity, the concept which is known as GARCH. Returns are assumed to be generated by a stochastic process with time varying volatility, that is important. I will highlight this. So, the volatilities are changing with respect to time, and that is where the actual in depth mathematical analysis comes, and practical problems are also there for this main concept. Mean or the first moment changing would not have that much of an effect as change of volatility. The concept of heteroscedasticity, homoscedasticity, collinearity, non-collinearities basically are so called fallout or the results of a changing variability. So, they have conditional distribution of the returns for the GARCH method, and in fact, conditional variance which is there in the GARCH has a sub part of time series which is autoregressive process. So, what we need to do is that consider the volatility as an autoregressive process and then go to the further stage trying to model the GARCH methodology. Now, what is the effect if we are certain that we want to use the GARCH method and the concept of volatility is changing with respect to time, and volatility is a autoregressive process. If it is there, what happens as an output? So, there are two major effects in which is found prevailing in the financial markets. One is volatility clustering happens, clumping of volatility, and sometimes it is very high, they are all clumped together, sometimes very low, they are clumped together. So, implies strong autocorrelation in the square returns, and the practicality is large changes tend to be followed by large changes of either sign, and small changes tend to be followed by small changes based on this. So, large changes are there, they are clustered together and they follow each other. So, they mimic for the duration of time, then small changes occurs, they mimic subsequently. It is not that abruptly large and small changes are side by side, they are clustered, that is why they are known volatility clustering. Now, this is at the data for a time series, financial time series, and if you find out the corresponding clustering. So, if I check the clustering, the blue line is basically the data, and if I concentrate on that, the clustering concepts which I see. So, I think this graph moved a little bit, this black one would have been here. Now, it makes much better sense, because rather than showing clustering as such, I wanted to show high clustering for high volatility at one end and low clustering for low volatility at another end. Yes, now it is better. So, I will save it. So, when you get the slides, there would not be confusion. So, if I look at the clustering and group together, I mark them with black and green. So, if I check the green one, you see the clustering are for low volatility. So, they are all clumped together. If I check the black one, black area, black means this one, where I am putting 2 tick mark, green is this one where I am putting 3 tick mark. So, all are clustered together, and generally it is not always necessary they would follow each other, but the clustering is more important, which needs to be noted, and that is why the AGARCH model for time series would be important. Because again I am mentioning, sorry for that repetition, the conditional variability is autoregressive process by itself. So, what is the other effect? Other effect is the leverage effect, especially from the financial concept. Companies use of borrowed funds to finance its assets, and when return on the capital employed exceeds the cost of the debt, that extra profit goes to the shareholder. So, which means that you leverage the factors as that once it is given to the shareholders, the general information flow would be such that there is a positive effect in the stock market, which will basically increase the prices and obviously volatility. If it does not goes, then the prices go down. So, clustering and leverage effects can be studied using the concept of AGARCH model. Now, we have a data set for the returns, and this is taken for the financial time series, which I do not have the time series in the Excel sheet, but as I said, once you get the final Excel sheet, all the data which you are discussing and some extra more would be added, which are specifically for the time series, and people can work on that using all the concepts we have studied. Now, there is strong autocorrelation for squared returns. So, if I consider the concept of autocorrelation, autocorrelation is basically they are correlated to each other depending on the lag. So, the results of the graphs which I am showing for the concept of autocorrelation, I am just generating using the data in the MATLAB, because that comes easy. But in actually what we need to do, if I follow the thumb rule, see for example, if I use the data here, say for example, I will remove this data set, but I am just showing, and if it has a lag of 1, so it will be shifted by 1 time frame. So, this is the actual data x t, and this is the actual data x t minus 1. So, I can have t minus 2 if it is shifted twice. So, what I need to do is basically find out the correlation between them. So, if I have this the correlation between these two data sets, The correlation is about 0.977, which is high. And obviously, if I plot it, let me do it with the let me shift it by 2 time frames. So, where the lags I am considering as 2. So, consider I also move it by 3. Consider I move it by 4. I will take it for 5 different movements and then find out the So, now I have the data, I will remove these one for simplicity for the calculation, and I will use the time series as done. So, this is x t minus 1. So, this is wait. Now, let me take it like this. So, this is t minus 2, t minus 3, t minus 4, t minus 5. So, these are the data sets. I will mark them here bold, and then I am trying to find out the correlation. So, obviously, there is autocorrelation because you are trying to find it for itself. So, I do it for the first one will be kept fixed, the actual time series. So, I copy it for the first and the just it should come here. Okay. I will get it. Correlation values are given. This is for the first and the third would be there. So, this is for the third. So, these are the autocorrelation which function which you see. So, here it is lag is equal to 1, this is for lag 2, this is for lag 3, lag 4, lag 5. So, these are the autocorrelation values for the lags as shown. I will save it because this what we have been doing in the MATLAB. We are visualizing it much better using the Excel sheet. So, if you see the lags changes from, I will only read the first 2 decimal 0.97, then changes to 0.95, then 0.92, 0.90, 0.88, and it will continue. But obviously, after some lag, if it falls rapidly goes to 0, that means the concept of stationarity will be coming out to be much more true. And if it falls slowly, if we have mentioned that, then non-stationary concept is overriding. So, this is basically for the DAX data. And we are taking the data from here. So, let us mark it, so there should not be any confusion on our part. This we are utilizing. So, I marked it. So, when you get the Excel sheet, you will be sure. Now, based on the squared autocorrelation or squared strong autocorrelation of the square returns, when you square it, I have just taken the data as it is. Now, the information may be important that we can find it for the logarithmic also, we can find it for the price minus the mean difference also. So, which is given in column A P, and you can find out for which autocorrelation is existing, not existing. So, it is very pronounced in intraday data, because there is lot of relationship how the prices for today in the second half would basically become based on the trading which is happening in the forenoon of the day. So, afternoon of the day would have be affected by the forenoon of the day prices. A basic test is Box-Pierce LM test, and based on that we can find out the strong autocorrelation concepts and other things. However, volatility clustering may still be present even though the data does not show strong autocorrelation. So, do not confuse autocorrelation and volatility clustering. So, autocorrelation may not be very strong, but still we can have the concept of volatility clustering as I showed. High volatility is grouped together or low volatility is grouped together. Causes may be negative skewness or extreme excess kurtosis on particular stocks. So, this I think I should discuss. I do not remember I have drawn these graphs, but I will still do it. So, what I am doing is I am going to take the log returns. So, the data size is quite huge, about 168, it should be sufficient for me to show. So, what I do, I am taking the DAX data only. I copy it. So, this is the DAX data, logarithmic of them. So, this is the data. So, I will basically break into two halves, not equal, two halves, where the negative returns are there, positive returns are there. So, I sort them out from the lowest to the highest, done. So, I go and take the values positive and negative separately. So, these are the positive values, these are negative values. Negative values, wait. So, this is negative value, this is positive value, and I will mark it with the heading. So, you can now I have the negative. So, they are not equal. So, let us see the number of data points for negative one is 79, number of data points for positive one is about 89. So, let me plot the histograms for the negative returns. This will be interesting. So, if I consider the number of bins, so this is negative in nature, negative skewed like this. That is what the word skewness was mentioned. And if I plot the positive one, see, it will change dramatically. So, it becomes skewed in the opposite direction. So, number of bins, I think I should So, should I do it like this? No, it is not coming. It should come exactly the same type of characteristics which I want. Yes. So this is basically like this. So, for right skewed, left skewed, considering the negative returns, positive returns, you will get these type of graphs. I am not saving it, because you can run it and do the yes. Now, I need to find out the mean, variance, skewness, kurtosis, mean value. Mean value is negative 0.08508. So, the average value for the whole data set, positive negative, was coming out to be almost 0, about 0.000 values. So, if I consider the positive average value, it is plus 0.0094. Variance, if I consider, I will consider the population one, because the data set is quite large, 79 and 89, which is fine, until unless we are too finicky about taking the sample of the population. So, it comes out to be 8.51 into 10 to the power minus 5. If I do it for the positive one, it is much less. It is about 6, no, it is not less. It is 6.33 into 10 to the power minus 5. So, if I do the skewness, so again for the population, is negative 2.54, and skewness for the positive one is positive 1.74, and we have seen that from the diagram. So, there is the diagram which you have shown is being doubly verified from the data. Kurtosis, for this positive one comes out to be 4.0, and for the negative one is 7.54. So, kurtosis is basically the flatness. So, let me save these data at least and highlight them accordingly. First one is mean, I was marking in yellow. Second was variance, I was marking in orange. The skewness, let me mark in another light color. Say for example, light pink, and kurtosis and all this thing, let me choose another color. Say for example, light green, done. So, you have these values here for the DAX data. So, the question can we do it for the Bajaj and all these things? Yes, we can do it. We have not done that, but because the discussion for skewness kurtosis came now, that is why I am discussing it. So, with this we have drawn the graphs of the PDF plots for positive negative. We have measured the mean value, measured the variance, measured the skewness, measured the kurtosis, and discuss about autocorrelation using the Excel sheet. Let us go back to the PPT slide. So, causes mainly negative skewness or extreme excess kurtosis on a particular stock, as in the values of kurtosis skewness we have already calculated. So, here is the return series for on data set, and you can plot the data sets also. We have not plotted it, we have plotted the PDF. So, let us plot it. I will not be saving the graph. So, but for the plots, if I plot it only for the negative one, not for both combined, and there are sorted. So, that information you won't be able to see, but I thought I will just display it accordingly. So, this is the graph. So, when I do it for the positive one, it is like this. These are the sorted one, not the combined positive negative one. So, what this here the last bullet point means, combining both positive and negative, you will have a negative skewness and extreme skewness. That values of skewness kurtosis, let me find out for which we have done it. So, this was given by pink color, the pink would be this, yes, and this was green, done it. Let me mark it bold and then I find out the values. So, this is for skewness kurtosis for the data, skew not p. This would be one data less, because we are starting from 6 and this I consider is the same data, because it is starting from AP 5, kurtosis I find CKURT for the same data set. If I copy it, one value less would be there for, because starting from 6. Very interestingly, the kurtosis for the log returns are plus 3.11, where those values were 7 and 5. So, quite stark. So, based on the present autocorrelation for a data set, autocorrelation for return series is given. So, you have autocorrelation, sample autocorrelation for raw return series and for the square returns that is given. So, if you see the bounds of how they behave. So, it is all square returns, obviously square being they are in the positive direction, here it is fluctuating, but square returns gives us a idea of autocorrelation being there. In equity market, it is observed that the volatility is higher in falling market. This is just observations and studies which show. Then in a rising market, it is cause of implied volatility skewness in the equity market is there and implies asymmetry in volatility clustering. So, we need to use E-GARCH and A-GARCH, exponential GARCH and autoregressive GARCH process. We will just mention it accordingly. So, the general equations for the conditional and mean equations would be a simple linear regression, which will provide a model for conditional mean of the linear process and also the conditional variance. So, that will describe the evolution of the conditional variance of the unexpected return process, because you remember variance is dependent on time and is increasing. So, now if it is increasing, hence important fact is there is a suffix t, because it is dependent on time. So, error process has time varying variance and it will basically, as I said, more than the mean value, the variability is important. So, if I look at the graph, so the mean value is there, but the variability keeps increasing. This graph I have drawn many times. So, with this I will end this 59th lecture and resume more about such examples for the time series in the next class. Thank you very much and have a nice day.